All right, well, let's get started. I like setting it up on this mode. This is because I can get to my controls down here and I can get to my ladybug and things like that. But electric forces and electric fields, that's where we're going to get through electric forces today, I'm hoping. So here we go. Well, let's just get started. How does electricity work? All right. Um, well, okay. Well, we're off to a great start. I couldn't even change the slide, so previous. All right, so here we go. There we go. All right, so hey, guess what? I got me a mouse, so now I'm dangerous. Anyway, the electric nature of matter is inherent in atomic structure. So you got the mass of a proton. These are your first four constants you need to know. Mass of a proton, mass of a neutron. We don't use this one too much. You chemists use this all the time. The mass of an electron. Now we know that this is not a accurate picture that these electrons are actually in a cloud like around the nucleus of the atom, but then we have the mass of the electron. So these are the two masses, and then we have what is known as the charge, which is in coulombs. Charge is in coulombs. That's the first thing you're going to learn is the charge. You might be thinking, oh, I thought it was in amps. No, amps is you think of the electric current. That's a measurement for current, and that's how many coulombs are going through a specific area in a certain amount of time. That's like the velocity of the electrons, for no other reason than it's the amount of stuff going through a certain area in a certain amount of time. That's current. We measure charge in coulombs, and this is the base unit. Now notice 1.6 times 10 to the negative 19 coulombs. So could I have, and that is and charge is quantized, okay? In nature, atoms are normally found with equal numbers of protons and electrons, so they are electrically neutral. By adding or removing electrons from matter, it will require a net electric charge with magnitude equal to E times the number of electrons added or removed. In other words, the amount of charge is quantized. Notice Q, which is in coulombs here, is equal to the number of electrons, or the number of net things there are, times the net charge, which is an electron. That made no sense. Let me start over again. Let's back up. Notice, this is the base charge, and it can be plus or minus. A proton is positive 1.6 times 10 to the negative 19 coulombs. An electron has negative times 10 to the negative 19 coulombs. Okay, so let's just do a sample problem. Maybe they give us one. How many electrons are in 1 coulomb of negative charge? Okay, so let's do that. How many electrons are in 1 coulomb of negative? So this is notes, lecture 1, page 1. All right, and of course I'll make a copy of these and put them in your box. Okay, so this is lecture 1. All right, so here we go. Lecture 1 notes. All right, so 1 coulomb of charge, 1.0 coulombs of charge is equal to N, and it's positive, so we're looking at the number of excess electrons. Since they told us it was a positive charge, so we're going to be looking for the electrons, E, here. Now remember, E is plus or minus 1.6 times 10 to the negative 19 coulombs. One of the things that Wiley Plus kind of does dirty to you is sometimes they carry it out to 4 sig figs. Okay, 1 point plus or minus 1. So we're looking for 1 coulomb of charge. So we say 1.0 coulombs is equal to N times 1.6 times 10 to the negative 19 coulombs, because that's as small a charge as we can get until we get down to quarks. And quarks have a third of that. All right, but that's subatomic, that's particle physics, and we don't quite get there in this class. So take 1.0 coulombs divided by 1.6 times 10 to the negative 19 coulombs. Notice the coulombs cancel. The coulombs here cancel, so N is just a number. And whatever that comes out to be, which they will tell us in the next slide. I don't have my calculator out. I promise I'll get it out next time. All right. Oh, and see, I like this because then we come right back to it. So boom, Q over E, 6.5 times 10 to the 18. That's a lot of them. All right, that's a lot of them. What's next? Okay, it is possible to transfer electric charge from one object to another. This is a good thing. This is what allows us to have our lights on and everything. This is where it all starts. Okay, the body that loses electrons has, so remember, here's the other thing. Let's go back to the notes. Only electrons move. Okay? Only electrons move from one body to another. So let's go to this guy. All right, so notice the ebonite rod. All right, it's rubbing against this animal fur, and these electrons jump up on it. All right. As a matter of fact, we're going to stop here, and I'm going to show you a little video of John Travoltage. Okay.